All right, in this video, we're gonna take a look at sample space and what happens with things called compound events. Sounds scarier than it actually is. So let's talk about sample space first. So sample space is the set of all possible outcomes in a probability experiment. So that is called the sample space. We can use three of the popular methods of creating sample spaces and recording them are lists, tables, and one of my favorites, tree diagrams. It's a nice visual to see what's happening to outline your sample space. So for this first one, I'm going to go ahead and use a list. We have James, Sarah, and Kara all want to shoot free throws. Use a list to find the sample space for the different orders in which they can shoot the basketball. Okay, so I like to take this one piece at a time. Let's let James shoot first because he's the first name I see. And then we could have Sarah shoot and Kara. Is this the only order that we can have of James shooting first? The answer is no. We could actually flip-flop this and we could have James shooting first and then Kara and then Sarah. The next thing I like to do is keep the front option consistent and adjust the back option. So let's have Sarah go first next. So if Sarah goes first, we could then have James and then Kara. And then if we have Sarah go first, we can flip-flop that and we could have Kara and then James. And lastly, we could have Kara go first, Sarah, James, Kara, James, Sarah. So those are all of the orders in which those three individuals can shoot free throws. So we have a total of 6 outcomes. So that would be our sample space of 6, and those are all of the options. Let's take a look at table and tree diagram form. And this is kind of all up to personal preference as to what works best for you. Like I said, I tend to gravitate toward tree diagrams, but you can kind of decide as we move forward. A sweatshirt can be purchased in blue, silver, or red. The sweatshirt can also be purchased with or without a hood. So that's a lot of different options we've got going on here. And we actually want to know what are all of the options that somebody could purchase this sweatshirt. So with a table form, what you want to do is have your 2 criteria of the color and the hood, and you would list your color and then the hood. So let's say we go with blue first. Blue, if you have a blue sweatshirt, you could have the hood. So I'll do yes for hood. So we have blue hood, or we could have blue no hood, N, no hood. We could go with silver. We could have the hood, or we could do a silver, no hood. We could do red is the last option. We could have a hood, and we could have red with no hood. So those are all of your options. Let's see, 2, 4, 6 options. And if we want to do this using a tree diagram, here's how this would look. So we would do, the color would be, B for blue, and you would have, hood or no hood, NH, no hood. So this is going to be a tree diagram working sideways. I could have silver, and I could have the hood, and I could have no hood, and I could have red, and I could have the hood and no hood. So that would be my sample space. So what this means, you would follow each one of these branches in the tree diagram, and that's your sample space. Those would be your options. So here I would have, the blue hood. Here I'd have blue no hood. I follow this branch, that's the silver with a hood, silver, no hood, red with a hood, and then red with no hood. So we have, yet again, 6 total outcomes. Oops, sorry, if you couldn't see that. All right, let's talk about compound events, which is doing a probability experiment more than once. So a compound event consists of 2 or more simple events, and a simple event is something like flipping a coin, rolling a cube, picking a card out of a deck of cards. That would be a very simple event. So a compound event is doing that simple thing multiple times. So for instance, flipping a coin 3 times, rolling a dice 3 times. So just like simple events, the probability of a compound event, so probability in general, it's a lot of fraction work. It's the number of desired outcomes out of the total sample space. So it's the number of favorable outcomes out of the total sample space. So this is where we're going to have to create the sample space to see what all of the options are. So this is where the tree diagrams, I think, come in handy. So suppose you flip that coin 3 times. We're going to figure out what the sample space is, and then we're going to figure out what the probability of flipping all heads would be. So here's what I like to do. Toss 1, you have 2 options. You're either flipping a heads or you're flipping a tails. Those are your 2 options. Toss 2, I'm going to connect with branches. Toss 2, I could get a heads or a tails. And if I flipped tails first, in my second toss, I would get a heads or a tails. And now the third toss, I kind of spaced these out too far and I apologize. I should have really condensed them in, but so this is toss 2 right here, and then toss 3 I'll do in green. So if I had a heads and a heads on the third toss, I could get a heads or a tails. If I got heads, tails, I could then get a heads or tails for that third toss. Heads, tails, heads, tails. So let's write out the sample space that we can figure out these probabilities, and I've got some questions down here as well to apply this knowledge. So our sample space, we would follow all possible tracks of these branches. So one option would be getting heads, 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 3 heads. We would also have heads, heads, tails, H, H, T. Heads, tails, heads. Now this is where order matters, so don't go flip-flopping them because we're talking about toss 1, toss 2, toss 3. Heads, tails, tails. So that's 4 options so far, and then we come down to tails being first. Tails, heads, heads. Tails, head, tails. Tails, tails, heads. And tails, tails, tails. Okay, how many options is that? That is 8 total options. So the probability of getting 3 heads in a row is 1 option out of 8 total. So 1/8 is the probability of flipping 3 heads in a row, which is not all that likely. Let's expand on this. What would the probability of getting 2 tails and 1 head? So this isn't talking about in order. This is just saying in general, what would be the probability of flipping 2 tails and a head? So let's go ahead and find those options. Here's 2 tails and a heads. Here's 2 tails and a heads. Here's 2 tails and a heads. Those are the only 3 options that have 2 tails and a heads. So that's 3 options out of 8 total. What's the probability of getting heads, then tails, then heads? So this is very order specific. So I have to find it in that order. So HTH, HTH is right here. That is 1 option out of 8. There is no other option where you have heads first, followed by tails, followed by heads. There's only 1 option. And this last one, okay, be careful whenever you see those inequality phrases. What is the probability of getting at least 1 head? So that means you could get 1 heads, 2 heads, or 3 heads. So it's 1 or more. So let's find all of the options that have at least 1 heads. That works. That has at least a heads. That has a heads. That has a heads. That has a heads, that has a heads, that has a heads. This is the only one that is not an option. So we have 7/8. So if you were to make a bet with somebody, and that's where probability does actually come into play, is gambling and betting. Not that I encourage you to do that, but it is a real world example of how probability can be used. The probability of getting at least 1 head has the highest probability. So if I had to make a bet, place money on getting either heads, all heads, getting 2 tails and a heads, or getting a heads, tails, heads, or at least 1 heads, I'm going with this because it's the largest fraction, which is the highest probability. So go ahead and work on that homework. It's part of your packet. It's a lot of sample space work with those compound events. Answer key will be on the website.